and we are back with your regularly scheduled programming with Welcome to Mathland, episode 314, Sampling and Linear Regression, a Group 7 production.
Production.
So today, what are we going to be doing? So, some basic information. Today, the question we have in all of our brains, we're going to be sending it out to you, is there a correlation between the publication date of a book and the synopsis length? So, in order to test this question, we have been given access to Mark Keppel High School's library, and what we were able to do is we were able to look at some of their books and take a look at their publication date and their synopsis length. So what we did in order to collect this data is, first of all, we organized the library into sections grouped by genre. What we did was we broke it down into three different sections because we have three people in our group, based on the physical location of the library, which also happens to group it by genre. On one side, we had our nonfiction area, and on the other side, we had fiction, and there was a third section that was more manga and more nonfiction books. After that, we had to set our boundaries. What is a shelf? So we chose some arbitrarily large number. For most of us, I believe it was 30. And what we did was we went down the shelves and we determined that a shelf would be an area that had a physical barrier on the left and right marking the length of the books. In order to choose the shelves, we randomly generated a number on our calculator, whether it be 1 through 5, 1 through 6, or 1 through 7, depending on the size of that shelf, and that gave us the row to use on the shelf. Next, we would randomly select a book in the row. In order to do this, like I mentioned earlier, we would generate a number between 1 and sometimes 30, sometimes 40, and sometimes 50, essentially an arbitrarily large number, and we would count that many from the start, or rather the very left of the shelf or the row. If the number was too big and the number resulted in us counting beyond the books in that row, we would just generate another number and disregard the previous number. After we have selected a book, we had to ask ourselves, what was the synopsis length and what was the publication date of the book we chose? In order to do that, we looked to the copyright information and found the publication date of that certain edition of the book, and we looked to sometimes the back and sometimes the flips of the book in order to count the synopsis length in words. After we collected the data for one book, we asked ourselves, have we covered all the shelves? Have we given each shelf an opportunity to be selected? And if our answer was no, we continued looking until we covered the entire library.
You'll notice in the picture there are over 20,000 books in the library. How is a three-man group going to cover all that? Well, you'll notice we divided the library into three sections based off the circles and the images. So we've split the main section into two parts based off the population of books and the rest of the library as the last third section. There's also many types of shelves, so our randomization has to be carried out in different ways, yet follow the same procedure, so that every book has an equally likely chance to be selected. Next slide. So to do this, we numbered the shelves as said before. As you notice, there's four types of shelves here. The first one on the far left has 6 rows, yet there's only books in 5 of them, thus numbered 1 through 5, top to bottom. Then in the next, there's 3 rows, top to bottom again. And then there's a slightly weirder shelf where it's 6 rows, all filled out with books, but there's also a spinning mechanism. Thus, they must be numbered 1 to an arbitrary number from left to right. And lastly, there's manga shelves such as the ones on the far right with 7 rows, also numbered 1 through 7, which we can then use a random number generator to calculate that number. You'll notice that we used our best friend, the graphing calculator, using the random integer function. By doing this, we can pick a number from 1 through 5, or the number of rows in a shelf. Thus, after picking that number, we select an arbitrary number, such as 20, 30, or 50, something that allows us to consider every book in the row, but still has numbers left over. But sometimes, the numbers are too large compared to the numbers of books in the row. Thus, we disregard numbers that are greater than the number of books in the row. As you can see, the handsome model on the far right, selecting a book from row 2, in which he selected a number from 1 through 30, thus selecting a number for the far left that looks like the number 2. Once selecting a book, he needs to look to for the synopsis of the book, counting every single word so that we can write down the data of words in a synopsis as well as the publication year, which is usually found, as said before, in the back or front of a book. As you can see in the picture of the zoomed in publication year, it says right there 1986 where it was copyrighted. Often books will say published in this year, but sometimes not all books say that. Thus, the copyright year is also the published year.
Some things to consider is that we found one outlier in our data collection, which was a book published in 1750 with a synopsis length of 1,108 words. This book was removed since it was an influential observation that could skew our results. And then we also labeled if the books were nonfiction or fiction to see if there were any patterns between the two types. This is the scatter plot for odd data. And then the line can be represented by the equation predicted synopsis length equals 1649.247 minus 0.772 multiplied by the published date. And then our y-intercept, 1649.247, represents the predicted synopsis length if the publication date was 0. And then our slope, which is negative 0.772, indicates that for each additional year in publication date, the predicted synopsis length would decrease by approximately 0.772 words. And then our r squared is 0.01991. And that means that only 1.99% of the variation in synopsis length is explained by publication date, which shows a very weak relationship. The residual standard deviation is 74.35, and that suggests that the predicted synopsis lengths typically vary from the actual lengths by about 74.35 words.
And as you can see in the residual plot, there is no pattern, meaning that a linear model is indeed appropriate for graphing all data.
Now we're looking at the data of all fiction books in the library. Looking at the equation in which the publication date, if there was a publication date of zero, if that were even possible, the predicted number of words would be negative 952.9491. And with every extra year in the publication date, another 0.5319 words would be added to the predicted value. Although our data is not very reliable, as r squared for the fiction books is 10.3%, in which only 10.3% of the variability is explained by our data. And our standard deviation value is 48.23 words, in which our data varies by 48 words on average, which is quite a lot, considering that our average synopsis length was around 100, which is half of our average synopsis length.
And now, yet again, we turn our eyes to the residual plot when there is no pattern. But wait, there's more. Did you catch that? There was a mistake. We'll give you, the viewers, 5 seconds to figure out what the mistake was on this slide. 1, 2, 3, 4, 5. Turns out, instead of saying 1.03%, we said 10.3%. Did you catch that? Are you paying attention? Okay, let's move on. Next, we have our data. This is the last part, we promise. And this is our scatter plot for the nonfiction books. As you can see, we have a very downward sloping graph, where if we had a supposed book with a publishing date of 0, it would have a synopsis length of 2,778 words. And for every extra year added to our publication date, we subtract 1.341 words from that beginning number of 2,778. So we see an r squared value of 0.0533, telling us that 5.33% of the variability in the synopsis length can be attributed to the 5.33% of the synopsis of the variability in synopsis length can be attributed to the publishing date, with a residual standard deviation of 86.6, which is also very great. Now, if you turn your eyes to the very bottom left, you see that there was a marking there and a line of influential observations. As you can see, there are many dots on that y-axis point. That brings up the question: did this make a difference? Did these influential observations have an influence? And the answer, like their name says, they did. Influential observations are data points that heavily influence the least square regression line, and as you can see, as this line is much more downward sloping than a previous line, these are indeed influential observations. Now, once more, turn your eyes to the bottom right, we see the residual plot, and it has, what's that? No pattern!
All right, now let's try it out. Here's a fiction book called The Handmaid's Tale. We use this equation right here for the predicted synopsis length. Um, the book was published in 1986 and it has a synopsis length of 104 words. Plugging in the 1986 into the equation, we get a predicted synopsis length of 103.4043 words. The residual, which is the difference between the actual and predicted values, is 0.5957 words.
Wow! This means that our prediction was less than a word off from the actual length of the synopsis. But wait, that that shouldn't happen. Didn't we say that the standard deviation was 60? We just got lucky. What does that mean? We'll find out later.
Conclusion. Now that was really lucky, but was it reliable? Was our data reliable? Of course not. Are you kidding me? Our R squared value barely didn't even explain 90%. It left out 90% of the variability. Not only that, but we had a huge standard deviation error value in which half our data varied by half of its average. But is that really what matters? What matters is, was our sampling method effective? Yes, it was. Our sampling method used a stratified sampling in which all book types were accounted for, which got rid of confounding variables and the risk of variables that come with genre and types of book, which are hard to randomize for. Not only that, but we utilize randomization in our sampling, the most effective, crucial part. Lastly, we went through the entire library. All 20,000 books were part of our sampling in which they had a chance to be selected.
But wait, didn't the least square regression line for fiction predict The Handmaid's Tale nearly perfectly? Well, yes, but you need to watch out for the law of small numbers. And if you're wondering what the law of small number is, just stick around. Coming up next, episode 315 of Welcome to Mathland.